Yo, what is up, guys? It's Ezo1000, and today I'm here gonna be showing you guys a tutorial with Desmos, graphing, very helpful for math, physics, anything to be honest, with graphs. Um, so yeah, this is Desmos. So I just graphed, as you can see, y equals x labeled in red. We can change the color if you want. This just actually erases the graph, but we can change the color here, and then we've got f of x equals x squared. Okay, so simple quadratic and you know um, a linear graph right here, and it shows us if you just click here for the main points like like the turning points and the x-intercept and y-intercept right here. So it's very very helpful, and even the points of intersection, right? If you go down, you can find the points of intersection right here, and I think you could even actually calculate the area with an integral. I think. Let me just see. I think you should be able to actually. Yeah, you can. You can calculate. So if you want to, you can even use an integral, and calculate the area from this point here, which is 0, all the way to this intersection here, which is x equals what? X equals 1. And you can calculate the area. Well, obviously you have to subtract it because it's the area between curves, and then calculate the area right there. But that's pretty cool, you know? Um, so yeah, that's Desmos, a simple introduction there. But I do want to show you, guys, a couple other things. So for example, we have this. I use this for my um, like IA stuff. So like different like chemical stuff graphs that I had here. So I had a simple rate of reaction graph here, and I had a line of best fit right there as well. So it's a pretty straightforward linear regression line. Um, so yeah, I created a table with concentration, and it was just testing the rate of reaction. So it was a linear progression, and then I created linear regression. It gave me the gradient and everything. So I plotted that down, and it gave us this graph over here, which is really cool, to sort of illustrate my data and analyze it. And then we also have this graph here. So this is another kind of linear regression. This one, as you can tell, the gradient is really steep. Like it's really, it's almost a complete vertical line over here. So the gradient's really steep here. As you can tell by the graph, it is. This was obviously just showing, looking at the final volume of different gas produced and comparing that to the concentrations of I think it was hydrochloric acid that I experimented with in this experiment, which is really cool. So you can interpret it and see, okay, it has a very steep, gradient. What does that mean exactly, right? Um, it means that the rate of reaction is obviously a lot faster, etc., etc., right? Because the quicker the gradient, the steeper the gradient, the quicker the rate of reaction, right? So this is some of that. Um, and then we also have this. So this was the initial one. It's a couple graphs that I plotted here, and as you can see by a couple tables over here, um, and labeled them as well, the different molars or chemical. Is actually molar means it's like the amount of substance available within like a volume of chemical or liquid. So this is the amount, right, available each time, and each time we increased it. So the trend is that the more you increase, the higher the rate of reaction, right? And as you can tell, it has a higher, more volume produced, right? As you can tell. So as you can tell first here at 0.2 molar, the time, okay, this is time versus volume. So it starts, a bit lesser, right? And then goes there, and it ends around here. So I all ended them at the same time to make sure we kept everything constant, right? Because that's independent variable. Um, and then obviously here, you look here, it becomes more steeper and steeper, which means that the higher the molar, like I said, the higher the more the rate of reaction. It reacts more faster. That means it comes to rest more quicker as well, which is a cool observation right there. And yeah, so this is just a little bit of how to show, how Desmos really works, and how you can interpret some of the graphs as well, just looking at the gradients, how steep they are, you know, um, doing it based off that, having a real life chemical application in this case with concentration, right, against time, and measuring the amount of gas produced in a reaction like this, which is really cool. And yeah, but you can really graph anything here, like a lot of data. You can stats. I'm not too sure if you can do stats, but you can, find the integral, find the area between the curves, like I showed you with the quadratic, and you can do a lot of stuff here. So yeah, it's a short intro to Desmos. I hope you guys enjoyed. I don't only do aviation here. It's kind of a different kind of genre here, but it's still pretty cool. It's meant to be educational, and I hope you guys learned something new. Let me know if you guys need any help with any Desmos tricks or whatever, because I have learned a lot of stuff from using this platform, and it's really helpful. So yeah, let me know. See you guys.